I'm happy to welcome you to the Bedtime Stories channel. Here, we delve into events of bygone days so that your sleep is light and informative. Don't forget to subscribe and immediately give the lecture a like, because by the time it's over, you'll probably be sound asleep. Close your eyes. My story is about to begin. The Bermuda Triangle is an area of the Atlantic Ocean shrouded in mysteries that have captivated the interest of researchers, sailors, and the simply curious for over a century. Numerous ships and airplanes have vanished without a trace here over the past 2 centuries, giving rise to many legends, from tales of supernatural forces to speculations about natural anomalies. Ships disappeared without sending distress signals, aircraft vanished into the sky without a trace of a crash, and search expeditions returned empty-handed. These cases formed the basis of fantastical stories, but behind them lie real events that require careful examination. Today, I will approach this topic from a scientific standpoint and examine key incidents, separate fact from fiction, and try to understand what is happening in this mysterious corner of our planet. My research is based on archival documents, eyewitness accounts, and collected information. We will analyze episodes where equipment malfunctioned in clear weather, communication was interrupted without obvious reasons, and crews disappeared without leaving any clues about their fate. These stories have often been embellished with fictional details, but I will focus on the facts to get to the truth. Let's start with the earliest mentions of missing ships, trace the evolution of this mystery in the 20th century, and consider modern attempts to explain what's happening. Each case provides an opportunity to examine what natural forces, human errors, or other factors may have played a decisive role. We will proceed step by step, revealing what lies hidden in the depths of the triangle and seeking answers where conjecture has long obscured the truth. To assess the scale, let's define the boundaries of this region. The Bermuda Triangle is located in the western part of the Atlantic Ocean and connects the points of Miami in Florida, Bermuda, and San Juan in Puerto Rico. Its area covers 1.5 million square kilometers, a space comparable in size to France and Germany combined, or almost half the Caspian Sea. These waters have been an important maritime crossroads for centuries. Trade routes connected the New World with the Old, airplanes crossed the ocean, and seafarers charted courses through this busy area. Maritime and aerial life thrived here, but it was also the site of events that made the triangle a symbol of the inexplicable. Legends about it multiplied with each new disappearance, blending reality and fiction. I will delve into this chronicle to examine genuine incidents, understand their possible causes, and understand what lies behind one of the most enduring mysteries of modern times. This journey begins with a clean slate, and discoveries and reflections await us. The early chapters in the history of the mysteries of the Bermuda Triangle open in the 19th century, when this part of the Atlantic Ocean had already begun to be shrouded in stories that went beyond the ordinary. One such episode was the meeting of the British ship Ellen Austen with a drifting schooner in 1881, a case full of details that turned it into a maritime legend. The Ellen Austen was crossing the Atlantic Ocean, following a route that passed through the area between Miami, Bermuda, and Puerto Rico. It was a Victorian-era trading vessel, a wooden hull reinforced with iron brackets, tall masts with taut sails, a crew of experienced sailors accustomed to the vagaries of the ocean. The day everything happened began quite normally. The sun was high, reflecting in the calm waters. A light breeze propelled the ship, and the horizon seemed boundless. At some point, a schooner appeared ahead, a small vessel drifting without any visible signs of life. The sails hung as if they hadn't been touched in a long time. The masts swayed slightly on the waves, and the deck looked completely empty, as if the crew had evaporated. For sailors of that era, Such a discovery was not unusual. Ships were often left without a crew due to storms, pirate attacks, or epidemics such as cholera, which claimed lives in the open sea. Such a vessel could become prey for those who found it, an opportunity to help the victims, or a chance to earn money by towing it to port. The captain of the Ellen Austin decided to follow maritime customs and send men on board. Several sailors lowered a boat and headed for the schooner. The waves lapped quietly against the sides as they climbed the rope ladder onto the deck of this mysterious vessel. An inspection showed that the schooner was in excellent condition. In the hold was cargo, perhaps sacks of wool, boxes of tobacco, or barrels of rum, neatly stacked and secured with ropes, as if it had just been checked before sailing. The sails, though hanging, were intact. The rigging was not torn, and the rudder turned with a slight creak, but without difficulty. The cabins showed signs of human presence. A worn book, open in the middle, a woolen cloak, a copper pipe with remnants of tobacco on the table next to a pewter mug. No signs of a struggle, bloodstains, broken boards, or signs of flooding. The schooner looked as if its crew had left the ship voluntarily, without haste, leaving everything as it was. The sailors remained on board to set the schooner in motion and follow their ship. The task seemed simple: raise the sails, take control, and escort the find to the nearest port, where it could be handed over to the authorities or sold for a reward. The weather up to that point had remained favorable, with a light wind and clear skies. However, soon everything changed. Clouds began to gather, the wind strengthened, and a storm was brewing. The waves rose, crashing over the sides, and the two ships temporarily lost sight of each other amid the veil of rain and flashes of lightning. The storm lasted several hours. Water poured over the deck, the wind howled in the rigging, and the horizon disappeared behind a gray curtain. When the storm finally subsided, the Ellen Austin returned to its previous location to find its men and the schooner. But there was no one there. The schooner had disappeared as if it had dissolved in the ocean, and with it, the sailors sent on board. The crew surveyed the waters around, peered through telescopes, listened to the silence, slowly moving in a circle in the hope of spotting something. No wreckage, boats, or hints that a ship with people had recently been there. The sea lay before them smooth and empty, as if the storm had swept everything clean. This case became one of the first oddities associated with the region that would later be named the Bermuda Triangle. The story of the Ellen Austin gained widespread attention much later, when it was written about in a newspaper in 1940. The story was based on oral maritime traditions passed down from generation to generation, but no documentary evidence, ship logs, official reports, or eyewitness accounts has survived. All that has reached us is based on this publication, which may have embellished the events to attract reader interest. Subsequent cases, such as that of the Mary Celeste, would add new strokes to this chain of inexplicable encounters in the same waters. The Mary Celeste departed from New York in November 1872, bound for Genoa. It was a two-masted vessel built in Canada, with a crew of 10, Captain Benjamin Briggs, his wife Sarah, their 2-year-old daughter Sophia, and 7 sailors. The hold contained barrels of denatured alcohol intended for Italian customers. The voyage began in clear weather, with a tailwind, and everything looked like a normal trip across the ocean. On December 4th, the British ship Dei Gratia, sailing from New York to Gibraltar, discovered the Mary Celeste hundreds of miles from the Azores, near the borders of what would later be called the Bermuda Triangle. Captain David Morehouse, who knew Briggs personally, noticed that the brigantine was moving erratically. The sails were half raised, and the rudder was swinging freely. Signals went unanswered, and Morehouse sent 3 sailors on a boat to inspect the ship. Going on board, they found emptiness. The crew had disappeared, but the ship remained in good condition. Barrels of cargo stood in the hold. One was broken, the rest intact. The sails and masts remained intact. The hull had no damage. In the captain's cabin lay navigational instruments, a map marked with the date November 25th, Sarah's sewing machine, and her daughter's toys. The sailors' bunks were made. Chests with clothes and tobacco were untouched. The ship's log ended with a record from November 25th with the coordinates of the island of Santa Maria. The lifeboat was missing, and the ropes were neatly cut. The compass was broken. About a meter of water was found in the hold, but this did not pose a threat to the ship, and the pumps were working. Food, money, and valuables remained in place. The Dei Gratia brought the Mary Celeste to Gibraltar, where an investigation began. British authorities inspected the ship, questioned Morehouse's crew, but found no signs of violence or illness. The alcohol in the barrels was found to be safe. The case went through the newspapers, adding fame to the region. The story of the Mary Celeste has been preserved in official investigation documents from Gibraltar and publications in the British press of 1872, such as The Times. These sources inspire confidence as they are based on the testimony of the Dei Gratia crew and the authorities' inspection of the ship. However, the absence of witnesses from the Mary Celeste leaves gaps. The investigation did not reveal the exact reason for the crew's departure, and versions differ. Some talk about panic due to alcohol fumes, which is refuted by the analysis of the cargo. Others refer to a storm, although the weather, according to meteorological data, was calm. Still others suggest that the crew left the ship in a lifeboat due to fears of flooding associated with the water in the hold, although its level was not critical. This version, about a mistaken fear of flooding, is considered the most plausible, given the disassembled pump and the absence of other obvious threats. Ahead of us is the story of the ship Cyclops, whose fate in the 20th century will reveal new facets of these mysterious disappearances. In 1918, at the height of World War I, the American collier Cyclops added a new chapter to the chronicle of disappearances in these waters. This vessel, unlike the sailing ships of the past, was a massive steel steamer, but its disappearance turned out to be just as inexplicable. The Cyclops belonged to the United States Navy and was used to transport coal and ore. It was a steamer 165 meters long, on board of which were the crew and passengers, a total of 309 people, including sailors, officers, and several civilians, including the U.S. consul in Rio de Janeiro. On March 4, 1918, the ship left the port of Barbados, heading to Baltimore. The cargo consisted of manganese ore, a heavy material for the steel industry, which was important in wartime. The weather that day remained favorable, with a light wind and clear skies, and the ship was in good condition after a recent inspection in port. The Cyclops was last seen off Barbados as it left the harbor. Radio communication with the ship was maintained during the first days of the voyage, but then it was interrupted. No distress signals were received, no reports of engine, cargo, or weather problems. The ship disappeared somewhere between Barbados and the east coast of the United States, in the Bermuda Triangle area. Search operations began when the Cyclops did not arrive in Baltimore by the appointed date, March 13th. The Navy sent ships and airplanes to survey the route, but no trace of the ship and 309 people was found. The ocean remained empty, as if the ship had dissolved in its vastness. The investigation organized by the U.S. Navy faced a complete lack of evidence. The Cyclops was a reliable vessel, built in 1911, under the command of Lieutenant George Worley, an experienced officer, although his German origin later gave rise to rumors of sabotage, not supported by facts. The weather in March 1918 along the route remained stable, without strong storms, according to meteorological reports. The cargo of manganese ore was considered stable, and overloading was excluded based on data from previous voyages. The story of the Cyclops has been preserved in official reports of the U.S. Navy and publications in the American press of 1918, such as the New York Times. These materials rely on data from the fleet and testimony from Barbados, but the absence of wreckage or radio communications leaves many mysteries. Explanations vary. Some point to a sudden storm not reflected in weather records. Others suggest an attack by a German submarine, although enemy activity was not recorded in the area. Still others talk about cargo instability or engine failure. The investigation failed to establish the exact cause, and no hypothesis received convincing evidence. The most plausible version is a hidden technical malfunction, possibly a hull fracture under the weight of the ore, which could have led to rapid flooding. Cases such as the disappearance of the Cyclops in 1918 left behind a trail of mysteries that could not be explained. Each such incident, from sailing ships of the 19th century to steel ships of the 20th, became a mystery surrounded by speculation. The waters of the Atlantic kept these stories, and around them gradually grew a myth. The fate of the Cyclops in 1918 left us facing the mystery of the disappeared steel giant, but the history of the secrets of the Atlantic is not limited to individual cases. It grows into something more, into a legend spanning centuries and continents. Stories about missing ships in these waters began to take shape back in the 19th century, when seafaring connected the world with trade routes. Sailors of that time shared stories about ships disappearing without a trace, passing them from mouth to mouth in port taverns. Some even recalled the records of Christopher Columbus, who in 1492 allegedly observed strange lights and compass malfunctions near the Bahamas. St. Elmo's fire, electrical discharges that occur on masts and rigging during a thunderstorm. They are mentioned in his diaries as a natural phenomenon, but are not associated with disappearances, and stories about Columbus in this context remain a myth. These rumors, born from the episodes we considered earlier, remained scattered until the 20th century breathed new life into them, combining old legends with modern disappearances. It was this myth that Vincent Gaddis shaped into a clear picture, giving it a name known throughout the world. As technology developed and reports of disappearances became louder, these stories began to attract attention beyond maritime circles. By the 20th century, cases of disappearances were accumulating, especially in the western part of the Atlantic, where routes between America, Europe, and the Caribbean intersected most often. The press picked up each incident, adding details and assumptions, which increased public interest. However, the real turning point came later, when one person managed to combine these disparate stories into a single whole, giving them a name that was forever etched in the minds of millions. In 1964, American writer Vincent Gaddis published an article in Argosy magazine, a popular yellow press publication, a cheap magazine that specialized in sensations, adventures, and unusual phenomena. The article was called The Deadly Bermuda Triangle and was the first to introduce the term to the general public. Gaddis brought together cases such as the Mary Celeste, the Cyclops, and others that had been talked about for decades, and described the area between Miami, Bermuda, and San Juan as a place where inexplicable disappearances occur. He relied on archival data, newspaper notes, and maritime reports, adding to them a dramatic style that captivated readers. In the article, he tried to explain the disappearances with a mixture of science and fantasy. He mentioned magnetic anomalies, referring to old stories about compass malfunctions, although he provided no precise evidence, talked about unusual weather phenomena such as sudden storms, and hinted at underwater currents capable of dragging ships down. In some places, he allowed for the intervention of extraterrestrial forces or mysterious energies, which particularly hooked the public. The publication in Argosy, with its circulation of hundreds of thousands of copies, sparked a wave of interest. Readers, captivated by the idea of a mysterious stretch of ocean, began to discuss it in letters, conversations, and even on the pages of other publications. Gaddis didn't invent these stories. He merely gave them shape, a name and a map, turning disparate events into a common legend. His work inspired the creation of books, articles, and research, and the term Bermuda Triangle quickly spread beyond the United States. By the 1970s, the idea had become part of mass culture, fueling curiosity about past cases and new incidents. He developed the theme in the book Invisible Horizons, 1965, where he added even more cases and assumptions, reinforcing the image of the triangle as a mysterious phenomenon. The story of Gaddis and his article in Argosy has been preserved in the original issues of the magazine and subsequent publications by the author himself, including the book Invisible Horizons, 1965. These materials are based on real events, but their dubious format, yellow press, and Gaddis's penchant for exaggerations, such as hints of the supernatural without evidence, call into question their scientific rigor, which is confirmed by comparison with the archives. Thus, a legend was born that united the rumors of the 19th century with the disappearances of the 20th, creating a phenomenon that we still talk about today. By the mid-20th century, these waters had become the scene not only for the disappearances of ships, but also for the loss of airplanes, expanding the boundaries of the mystery in the aviation age. One of the most high-profile cases that strengthened this reputation was Flight 19 in 1945. 5 U.S. Navy bombers and a rescue plane sent to help them dissolved into the air, leaving behind only fragments of radio conversations and new questions that still puzzle minds. On December 5, 1945, 5 Avenger torpedo bombers took off from a naval air station in Fort Lauderdale, Florida. It was a training flight under the command of Lieutenant Charles Taylor, a pilot with 2,000 flight hours, a veteran of World War II. On board were 14 people, Taylor and 13 cadets and instructors performing navigation and bombing missions over the ocean. The mission was standard: fly to Hens and Chicken Shoals, drop training bombs, and return via the Bahamas. The route ran through the area between Florida, Bermuda, and the Bahamas, an area already known for its oddities. The weather that day remained clear, with a light wind and good visibility, which promised a calm flight. The takeoff began at 2 p.m., and the group headed for the reef. An hour and a half later, alarming radio messages began to come from the base. Taylor transmitted, "Compasses are out of order. We don't know where we are." His voice sounded confused, which was unusual for an experienced pilot. One of the cadets added, "We're flying east, and we need to go west," indicating a deviation from the course. Then Taylor reported, "The ocean looks strange, not what it should be." The negotiations became more chaotic. The pilots talked about losing their bearings, even though the sun was still shining. At 4:25, another message was recorded. "We're entering white water. We're completely lost." White water is a term usually meaning foamy waves, but in clear weather, it sounded inexplicable and remains a mystery to this day. After that, communication was cut off. These messages are confirmed by base records, although interference and overlapping voices distorted some phrases. The base responded immediately. At 6:20, a Martin Mariner seaplane with 13 people on board took off to search. It was a vessel designed for rescue operations with a fuel supply for long hours. 20 minutes later, the mariner reported entering the search area, but soon communication with it also disappeared. That same evening, the Navy launched a large-scale operation. More than 20 ships and 250 airplanes surveyed an area of 300,000 square miles, including the Bahamas and the Gulf Stream. The search continued for 5 days, but no trace of the 27 people was found. The U.S. Navy investigation began the next day. Records of negotiations, the condition of the aircraft, and the weather were checked. The Avengers were in good condition before takeoff, with full tanks. Taylor was suspected of error. He could have mistaken the Bahamas for Florida and led the group into the open ocean. But the failure of the compasses on all the machines remained inexplicable. The Martin Mariner could have exploded due to fuel vapors. The merchant ship Gaines Mills noticed a flash in the sky at 6:30, but no evidence was found. The weather remained stable, without storms. Radio amateurs in Miami intercepted signals. One of them claimed to have heard the phrase, "It looks like we're over the Gulf of Mexico." But there is no confirmation of this. The case spawned many theories. Officially, the Navy leaned towards the conclusion that the Avengers had become lost due to compass failure, gone east, run out of fuel, and the Martin Mariner had exploded. However, the popularity of the triangle fueled rumors. Newspapers in the 1950s wrote that the mission could have been secret, a test of a new weapon or reconnaissance over the Caribbean, although Navy documents confirm only training. Other theories included abduction by aliens. The white water was interpreted as the trail of an alien ship or portal. There were also assumptions about temporal anomalies that carried the planes into another dimension, fueled by fantasies after Gaddis's article. These ideas had no evidence but were widely discussed in the press and books. This case was only the beginning of a series of aviation disappearances. 3 years later, in 1948, a Douglas DC-3 passenger plane dissolved in the same waters, leaving only a brief radio message and 32 people without a trace. This story adds a new layer to the chronicle of the inexplicable, taking us deeper into the aviation age. On December 28, 1948, a Douglas DC-3 departed from San Juan, bound for Miami, Florida. It was a charter flight of airborne transport, carrying 29 passengers, mostly Puerto Ricans returning home after the holidays, and 3 crew members under the command of Captain Robert Lindquist. The plane left San Juan at 10 p.m. local time, with a fuel reserve for 5 hours of flight. The weather remained favorable: clear skies, light winds, good visibility, ideal conditions for a night flight. 400 miles over the ocean, the flight was uneventful until midnight, when the Douglas DC-3 contacted dispatchers in Miami. Lindquist transmitted, "We are 50 miles from you. Everything is okay." It was the last message. The plane was approximately 180 miles from Miami, halfway through the Bermuda Triangle area. After that, communication was cut off. No distress signals, no hints of problems. When the Douglas DC-3 did not land at the appointed time, around 2 a.m. on December 29th, the dispatchers raised the alarm. The search operation began at dawn. The U.S. Navy and Coast Guard sent ships and planes to survey the route. The search area covered thousands of square miles, including the waters along the Bahamas and the Gulf Stream. Rescuers were looking for wreckage, boats, or oil slicks, but found nothing. One of the pilots reported a faint radio signal at 3 a.m., which may have belonged to the Douglas DC-3, but it quickly disappeared, and no precise confirmation was received. The search continued for several days, but no trace of the 32 people was ever found. The ocean went silent again, hiding another mystery. The investigation, conducted by the U.S. Civil Aeronautics Administration, faced a lack of evidence. The plane passed inspection in San Juan. The engines were working. The fuel was normal. Lindquist was considered an experienced pilot. His co-pilot and flight mechanic also had a good reputation. The weather that night remained stable, without storms or turbulence, according to weather reports from Miami and San Juan. The radio equipment was checked before departure, and it was functioning properly. The only clue is the message, "Everything is okay." But it did not indicate any problems. Although communication was cut off shortly after it, the case spurred various theories. Officially, a malfunction was suspected, perhaps engine failure or a fire, though the lack of a distress signal contradicted this. Some pointed to human error, a pilot miscalculation in navigation, but the route was straightforward and the night clear. Rumors soon surfaced, fueled by the triangle's notoriety. Talk turned to magnetic anomalies disrupting instruments, or a sudden, unrecorded storm. The 1950s press even floated theories of alien abduction, linking it to Flight 19, but evidence was also absent. The story of the Douglas DC-3 is preserved in U.S. Civil Aeronautics Administration reports and 1948 newspapers. These materials draw on air traffic controller accounts and search data, but the absence of wreckage leaves questions unanswered. The most plausible explanation is a technical fault leading to a rapid crash, but the precise cause remains undetermined. The last of the mysterious disappearances we'll explore is the Witchcraft boat, which vanished in 1967. This case occurred almost 2 decades after the Douglas DC-3, moving the Atlantic's mystery into the era of modern technology. What makes it stand out is its proximity to shore and the speed with which the vessel disappeared, leaving only silence where voices had recently been. On December 22, 1967, the yacht Witchcraft departed from Miami, Florida. It was a small, 7-meter vessel owned by Dan Burrick, a local businessman and boating enthusiast. On board were Burrick himself and his friend, Father Patrick Horgan. They planned a short trip along the coast to admire Miami's Christmas lights from the water. The yacht left the dock around 7 p.m., heading towards buoy number 7, located a mile offshore. At 9 p.m., the Coast Guard received a call from the Witchcraft. Burrick reported, "We have a problem. We hit something. Need assistance." His voice was calm, without panic, suggesting a minor issue. Perhaps the propeller had snagged on a reef or debris. He specified his location at buoy number 7, 1 mile from shore, and requested a tow. The dispatcher confirmed that help would arrive in 20 minutes and asked Burrick to launch a flare to aid the search. Burrick agreed, and the communication ended. The Coast Guard arrived at the buoy at 9:19 p.m., 19 minutes after the call. The sea was calm, visibility was good, and the lights of Miami shone in the distance. However, the yacht was nowhere to be found. No sign of the Witchcraft, Burrick, or Horgan. Rescuers scoured the area, searching for a flare, debris, or fuel slicks, but found nothing. The search expanded to 200 miles along the coast, involving Navy ships and aircraft. The operation lasted for several days, but neither the yacht nor its passengers were ever found. The vessel, just a mile from shore, vanished within minutes. The Coast Guard investigation was met with a blank slate. The Witchcraft was in excellent condition, recently inspected, with an inflatable life raft and life jackets on board, which Burrick hadn't had time to use. Buoy number 7 was in shallow water, about 5 meters deep, making sinking improbable without a severe storm, and the weather remained clear. The radio was working, and the signal was clear, ruling out communication problems. Witnesses on shore saw the yacht's lights until 9 p.m., but after the call, they disappeared. No reefs or obstacles were recorded in the area, although Burrick mentioned a collision. The case spurred various theories. The Coast Guard suggested the yacht might have sunk due to a hidden breach, but the absence of debris undermined this. Local sailors spoke of a strong current sweeping the vessel into the Gulf Stream, though its speed didn't explain the disappearance in 19 minutes. Other rumors included alien abduction or a sudden whirlpool, but there was no evidence. The 1960s press discussed connections to Flight 19, amplifying the mystique. These materials are based on radio recordings and testimonies, but the lack of evidence leaves gaps. The most plausible explanation remains a rapid breakdown and sinking, possibly due to a collision with an unseen object, but the precise cause remains undetermined. Disappearances in the Atlantic have, for centuries, confronted humanity with the inexplicable, prompting searches for causes hidden in these waters. The Bermuda Triangle, linked to numerous lost ships and aircraft, has become a place where science tries to solve the mystery. Among the fact-based hypotheses, magnetic anomalies stand out, a phenomenon related to the Earth's geomagnetic field, which can affect navigation in this region. The Earth is surrounded by a magnetic field created by the movement of molten iron in its core. This field guides compass needles toward magnetic north, helping navigators and pilots determine their course. However, the field is not uniform everywhere. In some places, it is distorted due to geological structures or changes in its lines of force. In the area known as the Bermuda Triangle, there is a unique situation. Here, true north, the geographic point where the meridians converge, and magnetic north, defined by the field, are closer to each other than in many other parts of the planet. This convergence creates a zone where compasses can deviate from the expected direction. Scientists record that in this area, the difference between true north and magnetic north, magnetic declination, can reach 10-15 degrees. For an unprepared person relying only on a compass, such a deviation could lead a ship or aircraft hundreds of miles off course. Historically, sailors noted such malfunctions in the Western Atlantic as early as the 19th century, when instruments began to show incorrect data for no apparent reason. Modern geophysical studies confirm the existence of such anomalies. Magnetometers used in the expeditions of the 1970s recorded local distortions of the field near the Bermuda and Bahamian reefs. These distortions are associated with underwater structures and the movement of magnetic lines connecting the equator and the poles. The scientific basis of this hypothesis relies on data about the Earth's magnetic field. The U.S. National Oceanic and Atmospheric Administration, NOAA, notes that in the triangle, the field is subject to variations that are enhanced by geological features of the region, such as shallow banks and faults. However, these anomalies are not destructive in themselves. They only affect navigation by throwing off compass readings. In the 20th century, with the advent of gyro compasses and satellite navigation systems, their impact became less significant. But for ships and aircraft of the past, dependent on simple magnetic instruments, this could have been a serious threat. The hypothesis of magnetic anomalies has been preserved in scientific works by geophysicists, starting with field measurements in the mid-20th century. These works rely on expedition data and observation of compass behavior in the open sea. It explains the navigation glitches, but leaves open the question of why some disappearances occurred even in clear weather or with experienced crews. This prompts us to consider other scientific assumptions, such as methane emissions, which I will discuss next. Our next hypothesis takes us below the ocean's surface to methane emissions, a natural process capable of drastically changing conditions at sea. This idea relies on the geology of the seabed and proposes a view of how some disappearances could have occurred instantly, leaving no trace in this turbulent corner of the planet. Methane forms deep in the sedimentary layers of the ocean floor, where organic remains, from ancient algae to microbes, decompose without oxygen under high pressure. This gas turns into methane hydrates, clathrates, frozen structures resembling ice. In the western Atlantic, such deposits are found in shallow areas and along the continental shelf, especially where tectonic faults disrupt the stability of the bottom. When temperature or pressure changes due to underwater shifts or currents, clathrates can break down, releasing gas bubbles that rapidly rise to the surface, sometimes forming columns hundreds of meters high. For ships, this creates a huge danger. Water saturated with methane bubbles sharply loses density. Instead of the usual 1,000 kilograms per cubic meter, it can become lighter by a factor of 10. A ship caught in such a zone instantly loses buoyancy and sinks in seconds without being able to send a distress signal. Experiments in laboratories in the 1980s showed that even a small vessel goes underwater almost instantly during such an emission. Scientists believe that large bubbles could sink large ships as well, and the wreckage was then carried away by powerful currents, like those that flow along the coast. Aircraft could also be affected by methane. The gas, escaping into the atmosphere, is able to rise to the altitude of flight, changing its composition. An engine that has drawn an air mixture with a high content of methane may stall due to failures in the process of fuel combustion. Turbulence from strong emissions can destabilize the flight. Geologists in the 1990s confirmed the presence of clathrates in the sediments along the Bahamian shoals, and underwater studies revealed craters and faults, traces of past gas breakthroughs. The methane emission hypothesis is reflected in scientific papers of geochemists since the 1980s. These works are based on the analysis of the seabed, laboratory tests in pools, and observations of gas emissions in other seas. It reveals how vessels could disappear without a trace, but its applicability depends on a rare coincidence. The emission must occur exactly under a passing ship or airplane. However, the surface of the ocean hides other forces, no less formidable. Among them are rogue waves, so nicknamed by sailors for their suddenness and destructive power, capable of rising up to 30 meters. This idea takes us to the dynamics of water masses, offering a view of how giant water peaks could cause disasters in this region. These waves occur when winds and currents converge at one point, amplifying each other. They can be 2 to 3 times higher than ordinary storm waves and appear suddenly. A calm sea is able to generate such a wall of water in a matter of minutes. For a long time, they were considered sea tails, until in 1995 the oil platform Dropner off the coast of Norway recorded a wave of 25.9 meters high. In the western Atlantic, similar conditions are created by the collision of warm and cold currents, especially where winds from the land meet ocean currents. Studies show that in this zone, such waves can occur more frequently than in some other parts of the world, thanks to the complex dynamics of the Gulf Stream and atmospheric fronts. Those who have encountered them and survived describe them as something overwhelming. One sailor in the 1970s recalled how off the coast of Florida, his ship was covered by a wave the height of a 10-story building. The ship heeled sharply, almost to the limit, but withstood, although everything on deck was washed away. Others spoke of a sound like a clap of thunder, and of how smaller boats disappeared at the moment of impact. Such testimonies speak of a force capable of breaking large vessels or dragging them underwater, leaving only rare wreckage. Oceanologists, with the help of satellites and measuring buoys, have established that along the path of warm currents in the western Atlantic, the probability of occurrence of rogue waves is increased. Computer models identify points where wave crests can be enhanced up to 30 meters due to a combination of wind pressure and current interaction. Airplanes at high altitudes remain out of their reach, But low-flying machines can get into the zone of strong turbulence created by such waves at the surface of the ocean. The work of scientists from the 1990s, based on satellite measurements, data from buoys and eyewitness accounts, supports this hypothesis, pointing to the hidden power of the ocean, which could have played its role in unexplained disappearances. Rogue waves showed how water masses are able to crush vessels in the western Atlantic. But even after such strikes, the question remains: where do the traces go? The answer may lie in the Gulf Stream, a rapid ocean current, which moves at a speed of up to 8 km/h, carrying everything that falls into its flow. This idea takes us to the dynamics of ocean masses, showing how nature could erase the evidence of disasters in this region. The Gulf Stream originates in the Gulf of Mexico and flows along the east coast of North America. In the area off the coast of Florida, it reaches a width of up to 100 kilometers and a depth of up to 800 meters, pumping millions of cubic meters of water every second. Its speed, reaching 8 km/h, distinguishes it from other currents, making it one of the most powerful ocean currents in the world. Warm waters, up to 25 degrees, move from south to north, bypassing the Bahamas and heading towards Europe, creating an invisible river in the ocean that dominates this corner of the Atlantic. When a ship or aircraft crashes, the Gulf Stream interferes with the search. Debris, lifeboats, or fuel slicks are picked up by this current and carried away for tens of kilometers in a matter of hours. For example, an object that fell off the coast of Florida may, within a day, find itself off the coast of North Carolina, 700 kilometers to the north. This makes rescue operations extremely difficult and sometimes almost useless. By the time search teams arrive, all traces are already far away or submerged deep into the eddies at the edges of the current. Oceanographers in the 1980s, with the help of drifting buoys, proved that objects in the Gulf Stream move at such a high speed, and turbulent eddies on its boundaries are able to drag them underwater. Sailors have often noticed how cargo from damaged ships was found hundreds of miles from the crash site. Airplanes themselves are not threatened by the current, but it also carries away their debris, greatly complicating detection. The idea of the role of the Gulf Stream relies on measurements of its speed, satellite data, and observations of the movement of objects collected from the mid-20th century. It points to how the ocean could effectively hide the consequences of disasters. Next, we turn to weather factors. Fast currents can carry away the traces of catastrophes in the western Atlantic, leaving rescuers empty-handed. However, these catastrophes themselves often begin because of forces acting above the water and not under it. Weather factors, hurricanes and microbursts, take us to the atmosphere, where wind and pressure create conditions that can destroy ships and aircraft. This idea relies on the power of the elements, which has left its mark in the weather archives of this region. Hurricanes are giant atmospheric vortices born over the warm waters of the Atlantic, where the surface temperature exceeds 26 degrees C. They form when moist air rises, cools, and condenses, releasing a huge amount of energy that spins winds to speeds above 118 km/h. In the zone between Florida and the Caribbean islands, the hurricane season lasts from June to November, with peak activity in September. The archives of the National Oceanic and Atmospheric Administration, NOAA, record their destructive power. In 1969, Hurricane Camille struck the coast of Mississippi with winds of up to 300 km/h, breaking vessels and flooding the land with waves 7 meters high. Such storms are capable of sinking ships and shooting down low-flying aircraft, especially if they fall into the zone of the strongest gusts of wind. Microbursts are another atmospheric threat, less extensive in area, but no less insidious. They occur in thunderstorm clouds, when a column of cold air plunges downward, hitting the surface at speeds of up to 160 km/h. Unlike hurricanes, they cover only a few kilometers, but their force is concentrated. The pressure of the descending wind can overturn boats or destroy the wings of airplanes on takeoff or landing. Weather archives have preserved an example from 1982, when a microburst off the coast of Florida tore a yacht from its anchor, throwing it ashore in a minute. Another case in 1978 was recorded off the Bahamas. A fishing vessel sank under a sudden gust of wind, although there was no strong storm in the forecast. For aviation, microbursts are particularly dangerous because of the sharp wind shear. Pilots who find themselves in such a zone on takeoff or landing face a sudden loss of altitude, which can lead to disaster. Meteorologists in the 1980s began actively studying and recording these phenomena with Doppler radars, discovering their frequency in the warm months along the Atlantic coast. Hurricanes leave a wider mark. In 1992, Hurricane Andrew passed through Florida, destroying dozens of vessels and ports and damaging low-flying rescue helicopters. Data on these phenomena are collected in the archives of NOAA and weather stations of the Caribbean region. They are based on radar readings, eyewitness accounts, and weather summaries from the mid-20th century. However, the weather in this region conceals more subtle phenomena, which are noticeable only from a height. Hexagonal clouds, found in NASA data, take us to turbulent zones above the ocean, where unusual structures in the sky can generate dangerous conditions for those who find themselves below. This idea relies on observations from space, revealing the hidden dynamics of the atmosphere over this corner of the planet. Hexagonal clouds are unusual cloud formations that stand out with clear geometric boundaries, resembling honeycombs. They form when cold air descends into layers of warm, moist air over the water, creating convection cells. Unlike chaotic thunderstorm clouds, these structures can take on a regular geometric shape due to the even distribution of descending and ascending air currents. NASA has recorded such clouds over the western Atlantic with satellites such as Terra and the MODIS, Moderate Resolution Imaging Spectroradiometer, instrument. In 1992, images showed them over the Bahamas, with the size of individual cells ranging from 30 to 80 km across, near the area where the warm waters of the Gulf Stream feed atmospheric instability. These clouds are associated with intense turbulence, which can reach the ocean surface. Meteorologists suggest that they form powerful descending airflows, similar to microbursts, but possibly acting over a larger area or with a different structure. NASA data for 1992 showed that such descending flows under hexagonal clouds are able to generate winds at the ocean surface at speeds of up to 160 km/h, colliding with water and raising waves up to 14 meters high. Studies using radars in the 2010s confirmed that over this region, turbulent zones associated with similar cloud structures occur more frequently in the warm months, when the temperature difference between water and air is enhanced. For ships, these conditions create a serious threat. Sudden gusts of squall wind can capsize boats or blow them off course. Airplanes, especially those flying at low altitudes, face sudden wind shears and strong turbulence, which disrupt control. NOAA weather archives mention cases, for example, in 1998, when a fishing vessel off the coast of Florida was caught under a sudden squall associated with a similar cloud structure and lost its cargo, although the sea remained relatively calm until that moment. The hexagonal cloud hypothesis is based on NASA satellite data and meteorological observations since the early 1990s. These materials rely on MODIS images and wind flow measurements, showing how geometric cloud structures can enhance local turbulence. They emphasize the role of the atmosphere in creating dangerous zones, but their impact is likely limited to certain weather conditions and is not a constant factor. Well, friends, we finally arrived at what you probably tuned into this lecture for, a pseudo-scientific show with a touch of fiction, where strict logic gives way to a flight of imagination. Hexagonal clouds left us with turbulent zones and serious science, but now it's time to dive into a world where anything is possible. Our first stop is Atlantis, the legendary island whose sunken technologies, as mystery lovers assure, still muddy the waters of the Western Atlantic, causing ships and planes to disappear as if in some ancient magic trick. This idea is rooted in ancient texts, prophecies, and bold fantasies, which I will now break down. Atlantis is first mentioned in Plato's dialogues Timaeus and Critias, written around 360 BC. The Greek philosopher described it as a powerful civilization beyond the Pillars of Hercules, i.e., beyond the Strait of Gibraltar, somewhere in the Atlantic Ocean. According to him, it was an island with advanced technologies, a huge fleet, a system of canals, golden walls, and temples, ruled by powerful kings, until everything was swallowed by the sea in one day and one night because of the wrath of the gods. Plato referred to the stories of Egyptian priests, passed on to the Athenian legislator Solon, but historians still argue whether it was a real story or an allegorical parable about the fate of self-important empires. Fiction writers and enthusiasts seized on this plot and attached it to the Western Atlantic. They claim that Atlantis lies somewhere under the Bahamian Shoals or in the Caribbean, and its sunken machines, whether energy crystals, electromagnetic emitters, or even anti-gravity devices, are still active. In the 1920s, the American clairvoyant Edgar Cayce added fuel to the fire. He claimed he had dreamed of the ruins of Atlantis off the island of Bimini and predicted their discovery in 1968. And lo and behold, in that very year, divers did stumble upon the Bimini Road, strange stone slabs underwater off the island of North Bimini. They were discovered by Dr. Joseph Manson Valentine, a biologist and lover of underwater mysteries, along with a team of divers. These slabs, up to 6 meters long, lie at a depth of 5 meters, forming something like a pavement, and enthusiasts immediately declared them to be the remains of an ancient civilization. But that's not all. In the 1970s, divers began reporting the discovery of pyramids on the bottom near the Bahamas. In 1977, an expedition led by American researcher Ari Marshall allegedly discovered an underwater structure 40 meters high off the island of Cay Sal, with smooth faces resembling Egyptian pyramids. They spoke of crystal clear water, where the pyramid appeared like a mirage, and of strange sensations, as if something was buzzing under their feet. These findings inspired theories that these are the energy stations of Atlantis, which emit waves that knock out compasses and engines. Some even suggested that the pyramids are connected to the Bimini Road, forming a single network controlled by ancient machines. Science, however, looks at this skeptically. Geologists studied the Bimini Road in the 1980s and concluded that it is a natural formation, beach rock, formed by cementation of sand and shells by tidal currents thousands of years ago. No trace of human processing was found. The pyramids off Cay Sal also turned out to be questionable. Subsequent expeditions and analysis of Marshall's photographs did not confirm the artificial origin of the structure. Many see in it only natural rock formations. Plato wrote about a catastrophe that occurred 9,000 years before his time, but archaeology does not know of civilizations with such technologies in that distant era. The first cities, like Jericho, appeared much later, without any hint of energy crystals or flying machines. Enthusiasts attribute magnetic disturbances and disappearances to Atlantis, but there is, alas, no evidence of this, only conjecture. The history of this theory lives in Plato's dialogues, Cayce's visions, and books like Charles Berlitz's The Bermuda Triangle, 1974. To it were added the stories of divers like Valentine, Marshall, and others. But all this relies on ancient texts, dreams, and controversial underwater finds, and not on verifiable facts. Atlantis remains a bright fantasy that excites minds, but does not stand up to scientific scrutiny, pushing us to the next popular version, the aliens, which we'll talk about next. The idea of alien involvement in the mysteries of the Western Atlantic began to take shape in the mid-20th century, when a series of unexplained disappearances attracted public attention. By the 1950s, magazines began to feature stories about strange objects in the sky, glowing spheres and disc-shaped silhouettes seen over the ocean. However, the real surge of interest came in the 1970s, when rumors of abductions and eyewitness accounts reached a peak. People began talking about the fact that aliens use this stretch of the Atlantic as a zone for their operations, perhaps taking ships and planes from here for study or experimentation. One of the most striking testimonials of that time was the story of a merchant ship captain who in 1972 reported seeing 3 orange lights hovering over his ship off the coast of Florida. He claimed that the lights moved in sync, then suddenly soared up and disappeared, leaving the crew in bewilderment. This case made it into the Miami Herald newspaper and inspired ufologists to new theories. In 1974, diver Robert Palmer, diving off the Bahamas, described how he saw a glowing object resembling a disc, which rose from the water and flew into the sky. His story was published in a magazine, where it was suggested that it was an alien ship that emerged from an underwater base. Rumors of abductions also multiplied. In 1975, a fisherman from Bermuda claimed that he saw a silver object hovering over his boat, after which he lost consciousness and woke up a few hours later at another point, 20 miles from the original location. His story appeared in Charles Berlitz's book, The Bermuda Triangle, 1974, where the author suggested that aliens could be taking people and vessels for their own purposes. Another testimonial came from a private airplane pilot in 1976. He claimed that he saw a huge triangular object over the ocean which radiated light and moved at an unnatural speed before disappearing. This case was discussed in the popular radio program Coast to Coast AM, reinforcing the belief in alien presence. These stories were fueled by the idea of underwater bases. In the 1970s, divers, such as Edwin Shucker, diving off the Bahamas, reported underwater lights rising from the depths. Shucker described them as pulsating points of light that moved underwater and then dissolved into the air. Ufologists, including Donald Kehoe, author of the book Operation Trojan Horse, 1970, associated this with possible alien bases under the ocean, from where they allegedly rose, leaving glowing trails behind them. Berlitz even suggested that the triangle is a kind of cosmic crossroads, where aliens conduct their operations, and the lack of debris is explained by their advanced technologies. The scientific community remains skeptical of these ideas. Neither NASA, the U.S. Navy, nor any other official body has documented tangible evidence of extraterrestrial presence in the area, despite numerous reported sightings since the 1950s. In his book, The Bermuda Triangle Mystery Solved, 1975, Larry Couchet suggested that luminous orbs could be meteors, ball lightning, St. Elmo's fire, or even the lights of other aircraft and ships. He attributed tales of abduction to either fabrication or psychological effects, such as disorientation or false memories induced by stress. Skeptics point out that radar and satellites have never confirmed the presence of objects exhibiting unnatural behavior, and eyewitness accounts remain just that, uncorroborated stories. The alien theory persisted through publications, Berlitz's books, and eyewitness testimonies from the 1970s, like the accounts of Palmer and Shucker. It leans heavily on anecdotal evidence and the imaginations of ufologists like John Keel and Donald Kehoe, who viewed the region as a hotbed of extraterrestrial activity. However, without any physical proof, this version remains a far-fetched hypothesis that captures the imagination, leading us to the next idea: temporal anomalies, which we'll discuss next. Temporal anomalies. This hypothesis transports us to the notion that the laws of time may be distorted in this region, whisking ships and aircraft into other dimensions or eras. One of the most famous cases supporting this version is Bruce Gernon's flight in 1970, which I will now dissect in detail. Bruce Gernon, an American pilot and businessman, embarked on his now famous flight on December 4th, not the 6th, as sometimes stated, 1970. He took off from Andros Airport in the Bahamas, headed for Palm Beach, Florida, in a small Beechcraft Bonanza aircraft. His father and a business partner were with him on board, 3 people in total. The roughly 100-mile route lay over the western Atlantic, an area known for its mysterious reputation. Takeoff occurred around 3 p.m., not 2 p.m., under clear skies, with light winds and good visibility. Gernon planned a routine 40-minute flight, carrying enough fuel for 3 hours and standard navigation equipment. Just minutes after takeoff, at an altitude of around 10,000 feet, 3,000 meters, Gernon noticed a strange cloud ahead. It resembled an enormous gray torus, or tunnel, with sharply defined edges, swirling walls, and flashes of light inside. According to him, it didn't look like a typical cumulonimbus cloud. It was incredibly dense, about 10 miles in diameter, and almost seemed artificial. Deciding to circumvent it, he began to maneuver, but the cloud, as he described it, moved and expanded, enveloping the aircraft. Soon, the Bonanza was inside. Visibility dropped to 0. The instruments, compasses, altimeter, radio, began to malfunction, and the needles spun erratically. Gernon later recounted seeing a bright light ahead, with the tunnel walls closing in, creating the sensation of flying through a narrow, spiraling corridor. The most remarkable thing happened next. After just a few minutes, according to his own time, about 3 minutes of flight inside the tunnel, the aircraft emerged from the cloud but found itself over the coast of Miami, nearly 100 miles from Andros. The flight, which should have taken about 45 to 50 minutes, effectively ended in 27 minutes, with more fuel left in the tanks than would have been expected under normal consumption. Gernon claimed that radar in Palm Beach registered his sudden appearance without any trace of him along the preceding route. He termed this phenomenon an electronic fog and suggested he had encountered a temporal anomaly, some kind of jump in time and space, which transported him across the distance far faster than is possible according to the known laws of physics. Science, however, questions these ideas. Meteorologists analyzing Gernon's case have suggested a possible atmospheric phenomenon, a rare type of thunderstorm cloud with extreme turbulence, or an optical illusion like superrefraction, where air layers distort the perception of distance and time. NASA and NOAA have not recorded any temporal anomalies in this region. Instrument malfunctions are attributed either to strong electromagnetic disturbances within a thunderstorm cloud or to a malfunction in the aircraft's electronics. Physicists, such as Stephen Hawking, who studied the theoretical possibilities of wormholes or rips in time, noted that their creation would require energy levels akin to black holes or exotic matter, which is obviously not present in the Bermuda Triangle. Radar data from Palm Beach, if they even exist in archives from 1970, have not been presented as irrefutable proof of a jump. It's possible that Jernin misjudged the time or distance traveled due to stress and disorientation in challenging weather conditions. Bruce Jernin's case has been perpetuated by his book, The Fog, a never-before-published theory of the Bermuda Triangle phenomenon. Initially, apparently, a manuscript or lectures later published, as well as publications by Berlitz and other ufologist authors. These sources rely on Jernin's personal account and the conjectures of paranormal proponents, who saw this as evidence of temporal portals. However, without scientific evidence, cockpit voice recorder data, which were often lacking in light aircraft of that time, independent observations, or physical traces of the anomaly, this version remains an intriguing but fanciful conjecture. Now, I turn to facts and figures to understand whether the Western Atlantic truly stands out among other stretches of sea. The Bermuda Triangle has long been regarded as an area where disappearances occur more frequently than anywhere else. However, statistics allow us to look at this from another perspective. Comparison with other hazardous regions, such as the Dragon's Triangle, Cape Hatteras, or Sable Island, helps to assess whether this area of the ocean is so unique, or whether its reputation is a product of sensational legends and extremely busy traffic. The Bermuda Triangle encompasses an area of approximately 1.5 million square kilometers between Florida, Bermuda, and Puerto Rico. During the 20th century, about 50 large ships and about 20 aircraft were recorded as missing here, according to data from NOAA and the U.S. Coast Guard. This number includes both well-known cases, such as the disappearance of the Collier Cyclops in 1918, and lesser-known incidents, such as small boats lost during storms. Thousands of ships and hundreds of flights pass through the triangle annually, connecting the ports of Miami, San Juan, and Bermuda, making it one of the busiest transport corridors in the Atlantic. For comparison, let's turn to the Dragon's Triangle, or Devil's Sea, in the Pacific Ocean, located between the islands of Honshu, Iwo Jima, not Okinawa, and Guam, off the southeastern coast of Japan. Its area is approximately 600,000 square kilometers, significantly smaller than the Bermuda Triangle. And during the same 20th century, Japanese maritime archives recorded approximately 40 missing ships, including 5 warships lost in 1952 during exercises, and the research vessel Kayo Maru No. 5 in 1952, not 1954. Powerful typhoons, reaching speeds of 200 km/h, and active underwater volcanoes associated with the Pacific Ring of Fire operate here, creating conditions no less severe than in the Bermuda Triangle. Other areas of risk are also impressive. Cape Hatteras, off the eastern coast of the United States, nicknamed the Graveyard of the Atlantic, has seen more than 1,000 shipwrecks in the last 400 years, from 17th century sailing ships to 20th century tankers such as the S.O. Greensboro, which sank in 1942 during a storm. Sable Island, located approximately 300 km, not 600, off the coast of Nova Scotia, Canada, has caused the death of about 350 ships in 300 years due to its shifting sandbanks and dense fogs, including the steamship Manhattan in 1903, not 1906. The Drake Passage between South America and Antarctica, with its enormous area of about 1 million square kilometers, is known for its extreme conditions. Incidents occur here every year due to waves up to 20 meters high and hurricane-force winds up to 150 km/h, as, for example, with the trawler Northern Wind in 1985. Larry Kusha, in his book, calculated that the percentage of disappearances in the Bermuda Triangle, considering the intensity of traffic, does not exceed the average figures for other busy sea routes. According to the U.S. Coast Guard, approximately 100 large ships were lost annually in the world during the 20th century, and only a small percentage, approximately 5 to 6% of all incidents in U.S. waters, not worldwide, occurred in the triangle. The figures are similar in the Dragon's Triangle. Japanese reports show about 3.4 unexplained disappearances per year until the 1980s, often associated with typhoons or navigational errors. Losses are historically higher at Cape Hatteras and Sable Island due to specific natural traps, shallows, fogs, but they are not surrounded by such an aura of mystery. Modern technologies such as satellite navigation, GPS, radar, and advanced rescue systems, EPIRB, have significantly reduced the number of unexplained incidents in the triangle. Since the 1990s, the number of serious disappearances has fallen to isolated cases per year, not 2 to 3, which is comparable to other regions of the world with heavy shipping traffic and difficult weather conditions. However, the figures are only part of the picture. Direct evidence from the depths is needed for a complete understanding. Submersible expeditions in recent decades have focused efforts on finding debris to determine whether the bottom of the Bermuda Triangle hides traces of missing ships and aircraft, or whether we are simply facing a void surrounded by legends. Since the mid-20th century, researchers have been trying to penetrate underwater in this region. In the 1960s, divers and small submarines began exploring the shallows off the Bahamas and Florida, hoping to find the remains of ships or aircraft, such as Flight 19, which disappeared in 1945. However, early attempts often ended in disappointment. Strong currents, such as the Gulf Stream, carried away light debris, and the shifting sandy bottom quickly buried them. In 1986, an expedition from the National Geographic Society of the United States discovered the sunken cargo ship SS Cotopaxi off the coast of Florida, which disappeared in 1925 with a cargo of coal. Its hull lay at a depth of approximately 100 feet, 30 mm, but this was more of a rare exception, confirming the rule of the danger of storms rather than a rule of unexplained disappearances. Deeper waters, reaching 2,000 meters or more in the central part of the triangle, remained inaccessible until the end of the 20th century. In 1991, Robert Ballard's team, known for finding the Titanic, searched the area north of Bermuda using deep-sea vehicles. They found several small pieces of debris, pieces of metal and wood, but nothing that could be definitively linked to large ships or aircraft from the list of known disappearances. In 2015, a NOAA expedition with the deep-sea vehicle Okeanos Explorer surveyed the bottom off Puerto Rico, discovering only natural structures, underwater canyons, sedimentary layers, but without clear traces of man-made objects in the explored areas. These efforts highlight the complexity of the task. Debris, if it exists on the bottom, is either carried by powerful currents far from the crash site or buried under a thick layer of sand and silt at great depths where costly and complex expeditions rarely reach. NOAA data shows that less than 10% of the bottom of the Bermuda Triangle has been mapped and explored in detail. Finds like the Cotopaxi are often associated with known storms or established causes of the crash, and not with mysticism. However, the technologies of the late 20th and early 21st centuries have opened new opportunities for exploring the bottom. Sonar and remotely operated underwater vehicles, drones, ROVs, have become tools that allow us to look where divers cannot reach, exploring objects such as the Bimini Road and other underwater anomalies, to separate natural structures from legends about the sunken mysteries of the Bermuda Triangle. Sonar, sound navigation and ranging, uses echolocation to map the bottom relief and search for objects. In the 1980s, side-scan sonar began to be actively used to search for sunken ships. In 1987, an expedition off the Bahamas using sonar discovered debris that some linked to a Douglas DC-3 aircraft that disappeared in 1948 at a depth of about 100 meters, but the identification remained controversial. More often, sonar records vast empty sandy plains or natural sedimentary rocks, as, for example, in 1995 off San Juan, where no traces of large anthropogenic objects were found in the search area. In 2001, Canadian researchers Paul Weinsweig and Pauline Zalitsky used sonar off the western tip of Cuba and discovered symmetrical, geometrically regular structures at a depth of about 700 meters, which they linked to myths about sunken cities. However, subsequent analysis by geologists showed that these are most likely natural geological formations, possibly of volcanic origin or the result of sedimentary processes. Underwater stone slabs near North Bimini Island, Bimini Road, have become one of the most famous finds. They were first noticed by diver Joseph Manson Valentine in 1968. Sonar studies in the 1980s confirmed their size and structure. Slabs up to 6 meters long lie at a depth of 5 meters, forming a strip about 700 meters long. Enthusiasts saw this as a trace of an ancient civilization. However, detailed studies by the U.S. Geological Survey in 1997 and later showed that this is a typical beach rock, limestone formed by the natural cementation of coastal sediments thousands of years ago without any signs of artificial processing. Underwater drones, ROV, remotely operated vehicles, have also expanded search capabilities. In 2014, a NOAA expedition with the Hercules drone surveyed the depths off Florida, finding and identifying the remains of the steamship SS City of Washington, which sank during a storm in 1917, not 1926, at a depth of about 40 meters. In 2016, drones explored the area north of Bermuda, discovering scattered metal fragments, but their origin remained unclear. Perhaps it was just garbage or parts of old cargo. The Bimini Road was also targeted by drones in 2018, which once again confirmed its natural origin, without traces of mythical technologies. Data from sonars and underwater vehicles are stored in the archives of NOAA, the U.S. Geological Survey, and other oceanographic institutes. They emphasize that most of the finds in the triangle are either rare debris from known crashes with established causes or natural geological objects. Now I am summarizing. What remains of the legends of the Bermuda Triangle when facts take over? Science has answered many questions, but has it left room for new mysteries? Statistics have revealed that the number of unexplained disappearances in the triangle, adjusted for traffic intensity, is no higher than in other dangerous but busy maritime areas. Underwater expeditions and modern tools have shown that debris from mysteriously missing ships is rare, and the bottom more often turns out to be empty than full of traces of unexplained disasters. The National Oceanic and Atmospheric Administration, NOAA, and the U.S. Coast Guard note that the vast majority of disappearances, about 80% or even more, are associated with quite earthly causes: severe weather conditions, hurricanes, storms, sudden squalls, crew errors, navigational miscalculations, insufficient training, human factor, or technical malfunctions, engine breakdowns, equipment failure, design defects. Storms, navigation failures, and equipment malfunctions explain the fate of most ships and aircraft, leaving very little room for mysticism and fantasy. Larry Kusha, in his book, convincingly argued that the Bermuda Triangle is largely a myth that grew out of incomplete information, exaggerations, and a desire to find a mystery where there is none. Modern data confirms that with the development of technology, GPS, radar, communications, and rescue equipment, since the 1990s, the number of unexplained cases has sharply fallen to isolated incidents per year, which is comparable to other areas of the world ocean. However, some disappearances still remain without a definitive answer, and the immense depths of the ocean, up to 3,000 meters or more in some parts of the triangle, still hide their secrets. Only a small part of the bottom has been studied in detail. Science sees the Bermuda Triangle as a whole as an ordinary, albeit difficult to navigate due to weather and currents, area of the ocean. But its legend, fueled by decades of publications and popular culture, continues to live, leaving room for imagination and reflection. Thank you for taking this journey with me, exploring the mysteries of the Bermuda Triangle from legends to facts. If you enjoyed this, subscribe to the channel, like, and share your thoughts in the comments. Until next time.